and how they are impacted by the coupon rate or the yield to maturity or the number of periods to maturity or the fraction of the coupon period that has gone by. And this is of course very interesting. Out of all of them are interesting, but this particular one is very interesting. And before we get into that, let me just remind you that this is the formula that we looked at in the learning module for Macaulay duration, the previous learning module. And I had told you that don't worry about it too much, right? The calculation of Macaulay duration or the formula for Macaulay duration, because it's not very likely that you will have to calculate Macaulay duration using this formula or through that entire table where you take the present value and then weight it with each of the years. You'll most likely be given the Macaulay duration, and you can use that to calculate the mod D and money duration and PVBP. But why I am showing you this formula here now is just to help you understand what is the impact on MACD of various properties of a bond, such as its coupon rate being high or low, or its duration, maturity being high or low, right? So that is what we're going to discuss through this formula, right? Starting with the time to the next coupon, right? And as you get close to the next coupon, what happens, and let me show you in a graphical manner. And please, we have to read this diagram from right to left. So as you are going through the life of the bond, as you get a coupon, right? So let's say you get a coupon on this date, what happens is that the Macaulay duration jumps. And why is that? Now let me go back and show you. So see, as you're getting close to a payment, so let's say 50 days have passed, right? And now 90 days have passed, or 150 days have passed. So this figure over here, which is T divided by T, is getting larger and larger. So as this gets larger, your MACD comes down, down, because that coupon is coming closer. And try to understand that MACD goes down with reinvestment income of coupon, right? And it goes up with price risk. So the sooner the reinvestment income overpowers, dominates the price risk, the sooner you reach your Macaulay duration. So with the coming closer of each coupon, what happens is that it's increasing the power of that reinvestment income because the coupon is coming closer. But once the coupon is paid, then the MACD jumps again, right? So this is one thing that you need to understand, that what is the impact of coupon dates on your MACD. Number one. Number two, we're going to talk about some other type of bonds. One, let's say, for example, that doesn't pay any coupons. And this is something we talked about in the previous video, that because the entire payment is coming at the end of the maturity, there is no coupon, so therefore there is no reinvestment income, and therefore its Macaulay duration is just going to be equal to its maturity. Whatever is the maturity, that is the Macaulay duration, because there is no weighted average number of years to get your money back. You will get your money back when the bond matures, because there is only one payment and it's going to come at maturity. And there's no reinvestment income because there are no coupons. It's just complete price risk, right? Number one. Number two, with respect to a perpetuity that never gives the principal back, it just keeps paying coupons. So the Macaulay duration for that is 1 plus R divided by R. And the higher the R is, the lower the MACD for this would be, right? So let's say if you want 10% R, that's going to be 11 years, right? If you want a 5% R, so that's going to be, I believe, 21 years, right? So Why is that? Because obviously if there's a higher return that you're getting your money back sooner. So if I give you $100 and you're paying me 10% every year, well, in the 11th year my money is already back, right, after adjusting for time value of money. So whatever the R is, the Macaulay duration for the perpetuity is 1 plus R divided by R. Now that's straightforward. Perpetuity is easy to understand. Zero coupon bond is easy to understand. What are interesting is the discount and premium bond, right? And I'll take you through both of those with respect to the formula. So let me just rediscuss your zero coupon bond from the formula. Again, I'm sure you understand it even without the formula, that since there is no coupon, therefore there is no reinvestment income, and your Macaulay duration will be the time to maturity because all that money is coming back on the maturity. However, if you want to understand it from the formula as well, the way we can do that is we say, okay, since there is no coupon, so C is 0. And if I plug in 0 over here, what happens is that this n will get multiplied to minus r, right? And if you multiply n to minus r, what you will have is minus nr, right? And then that plus 1 r, 1 plus r minus nr over, and this is 0 as well. So this entire thing becomes 0. Right, this entire thing becomes 0, and you have that plus r left in the denominator, and on this side you have the 1 plus r over r. So if you subtract these two, this 1 plus r and this 1 plus r gets cancelled, and then what you have left is this minus minus makes this a plus. So what you have left is n r over r, and then the r gets cancelled, and what you have left is just n, and that is your time to maturity, which is equal to your Macaulay duration. And this is obviously, there's no coupon, so there's no t for that, right? So that's how you can derive this through the formula as well. Perpetuity is going to be 1 plus r because obviously there is no coupons. Sorry, there is no maturity. There is no maturity. This is an infinite number. So if you have that infinite number in the denominator, it becomes a very large number, and it makes this whole thing equal. This whole thing becomes 0 because it has infinity in the denominator, and it just makes it equal to 0. Now you might be thinking it also has infinity in the numerator. Yes, you are right. It does have infinity in the numerator, but this is an exponential infinity, right? The denominator has n as an exponent. So it just makes it such a huge number that the only thing that is left is that 1 plus r divided by r. Now this is very interesting. Your premium bond, why it is below perpetuity and why your discount bond goes above perpetuity. So this is very interesting, and let me remind you with the formula again. See, what is a premium bond? A premium bond is where the coupon is greater than the market interest rate, right? And therefore people are willing to pay a premium for it. So if the coupon is greater, that means this C minus R is going to be a positive number. And if this is going to be a positive number, this entire thing is going to be a positive number. And if this entire thing is going to be a positive number, and since it is getting minused from 1 plus R divided by R, therefore the premium bond is always less than 1 plus R divided by R, right? So the Macaulay duration for a premium bond is always less than 1 plus R divided by R, and then it approaches that, but it's less than it. However, with a discount bond, what's happening is that this thing is going to be positive. This entire thing is going to be negative, which means obviously negative will become positive. Because why is it going to be negative? Because the coupon rate is less than your required rate. So this becomes negative, which makes this entire thing negative. And then of course negative becomes positive, and then it increases. So even though it starts off, and let me just go back and show you from the previous one, even though it starts off lower, but as your time to maturity increases, it goes higher the Macaulay duration goes higher than 1 plus R divided by R, and then it comes back down as the maturity is there. Right, and that's because this entire thing is negative, and negative becomes positive, and the MACD goes higher than the 1 plus R divided by R. Right, and now this is the very important point from an exam focus, because what is the concept here which can be tested is that what is the relationship of MACD to coupon rate. And there's a summary coming up for this as well. What is the relationship with yield to maturity, right? And think about it in terms of reinvestment income. Reinvestment income of the coupons. So naturally, if reinvestment income is higher, your MACD is lower, because the sooner the reinvestment income overpowers the price risk, it over dominates the price risk, the sooner you reach your MACD, right? So if reinvestment income is higher, your MACD is lower. And how will your reinvestment income be higher? If the coupon rate is higher, or the rate at which you can invest the coupon is higher, right? So therefore, coupon rate and the interest rate are both inversely proportional to your MACD, because if higher coupon rate or higher interest rate reduces your MACD, therefore they are inversely related. And that is what this curriculum, this exhibit from your curriculum is showing you, that the coupon rate and the yield to maturity, the YTM, the interest rate, are both having an inverse relationship with your MACD, because the higher the reinvestment income, the quicker you reach your MACD. Now, on the other hand, your time to maturity is having a direct relationship, because the longer your time to maturity, the more your future payment is getting stuck, and definitely it is going to increase your price risk. Now, fraction of the coupon, and this brings us back to that discussion where it was jumping like this, right? So as that fraction goes up, your MACD comes down because your coupon is coming close, but then as soon as it kind of resets, then the MACD jumps again. But as far as the fraction is concerned, as it goes up, the MACD comes down. So it also has an inverse relationship. Right, so that is it for this learning module. We talked about how you calculate mod D using MACD, right? And we talked about the approximate mod D as well, where you shock the yield 1% or 0.5%, and you calculate the price when you're shocking the yield downwards, which is PV minus, and shocking the yield upwards, which is PV plus, and you calculate the slope based on that. You can then of course calculate your money duration based on that by just taking your mod D, multiplying it with by the price, and then you can take your money duration multiplied with the change in yield to get the change in price. And if you want the change in price for 1 basis point, you can just take your money duration and multiply it with by 1.0001, or you could use this formula where you shock it by 1 basis point upwards, 1 basis point downwards, and take that difference and divide it by 2. And of course, we looked at how coupon rate or yield level or maturity affects your MACD. So if you're in the low interest rate environment, it's going to be that your reinvestment income is low, versus if you're in a high interest rate environment, then your reinvestment income will be high and your MACD will be low. So that is how your yield level affects it, right? Lower YTM, higher duration, and higher YTM, lower duration. Again, lower coupon, higher duration, higher coupon, lower duration, because higher coupon and higher YTM means higher reinvestment income. So they are inversely proportional to your duration, Macaulay duration, higher, higher, and lower. So higher coupon, higher YTM means lower Macaulay duration. On the other hand, your time to maturity is directly proportional to it, because not directly, but it is positively linked to it. So a longer time to maturity means a longer duration, right? A higher duration, and a shorter time to maturity means a shorter duration because you're getting your money back sooner. So that is it, guys, for this learning module. Hope you enjoyed it. Of course, you can rewind and watch the video again. Do solve a lot of questions from your question bank, and wish you the best of luck and hope to see you in the next learning module.